Good morning, afternoon, evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today, guys, we're going to learn how to solve radical equations. And a radical equation is an equation that has a variable in a radicand, okay, or a variable with a rational exponent. In this lesson, assume that radicals and expressions with rational exponents represent real numbers. And I made a little bit of a mistake here. In a no, it is in a radicand. Yeah, the radicand is the variable. Yeah, okay. So the procedure. Guys, this is, believe it or not, just like solving any other equation. You want to get things alone, okay? So the first thing you want to do, my brothers, is isolate the radical. So if something's being added to the outside of the radical, get rid of it. If something's being multiplied to the outside of the radical, get rid of it. If something's being divided to the outside of the radical, get rid of it. I need you to understand that it's to the outsides. A lot of times you will see x plus 2, let's say, equals 9. And people will subtract 2 to both sides. That is wrong because the 2 is inside of the radical. The 2 is part of the radicand. What you need to do is, if I'm adding, let's say, a 4 here, now you can subtract 4 to both sides. Now you got the radicand by itself. Now you can start rocking and rolling and going from there. Okay? But you got to isolate the radical. What's inside of the radicand, you cannot get rid of that until you get rid of the radical sign. It's kind of like an absolute value. Very well put, my brother. Very well put. Number 2, cancel out or eliminate the radical by raising both sides of the equation to the power of the index. Guys, if you have a square root, you get rid of a square root by squaring both sides. If you have a cube root, you get rid of the cube root by cubing both sides. If you have an index of 5, you get rid of that by raising it to the 5th power. Step 3, solve the resulting equation and check for extraneous solutions. You got to check for extraneous solutions. What on earth is an extraneous solution? Well, we talked about that with absolute value. An extraneous solution is a solution that you get, but it doesn't work. So, for example, maybe the answers you get were 7 and negative 5. Okay, those are answers. That's great. But when you plug those in, maybe the 7 doesn't work. That would be called an extraneous solution. Sometimes the solutions that you get do not work. So when a solution to an equation does not work, that's called extraneous. It is a solution, but it's an extraneous solution. So on a test, you must label that. Let's say x equals 5 and negative 4. 5 works, great, but negative 4 doesn't. You cross it out and put extraneous next to it. Similar to what we did with absolute value. And literally, guys, no joke, that's the lesson. So let's do it. I'm going to go ahead and isolate the radical. I want to get the radical by itself, so I'm going to add 5 to both sides. So I've got the square root of 4x plus 1 equals 5. How do I get rid of a square root, my brothers? Squaring it. Very good. Whatever I do to one side, I must do to the other. So 4x plus 1 equals 25. Subtract the 1 to both sides. 4x equals 24. Divide by 4, my brothers. And x equals 6. Excellent. Way to go. Now you can plug it in. 6 times 4 is 24 plus 1 is 25. Square root of 25 is 5. 5 minus 5 is 0. It works. Okay? Next, I got 3 plus square root of 2x minus 3. I'm going to subtract the 3 because I want to isolate that radical. I'm going to square both sides. I square to get rid of this square root. If it was a cube root, I'd have to cube it, guys. So I've got 2x minus 3 equals 25. Add the 3 to both sides. 2x equals 28. Divide by 2, my brothers, and x equals 14. Let's see if that works. 14 times 2 is 28. 28 minus 3 is 25. Square root of 25 is 5. 5 plus 3 is 8. It works. Does that make sense, guys? Promise? Okay. Tell me what to do. Subtract the 2. Good job. Well done.
Square both sides.
Okay, you're going faster than me, and I love it. Go. I'm on it. Square both sides, you said. Go.
3x plus 10 equals 4.
Those cancel. Beautiful. I heard like 4 of you say it. Excellent. That equals
Minus 10.
4. Subtract 10. Thank you, my brother. Yeah. Perfect. Perfect. I hope everyone out there in the internet world saw what I was doing. My class was just telling me what to do, and what they did was perfect. Okay, they squared both sides, got rid of the radical, subtracted 10. 3x equals negative 6, divide by 3, negative 2, and it does work. 3 times negative 2 is negative 6, plus 10 is 4. Square root of 4 is 2. 2 plus 2 is 4. Bam, done. Great job. Does that make sense, my brothers? Okay, tell me what to do. Yeah. I like it. I like your style, my brother. Square both sides. Yes. Go. You got this. You got this. Keep going, my man. Oh, wait, hold on. Now we're going too fast. Got rid of this. Hold on. That's 4. Add the 1, right, my brother?
5x equals 5. X equals 1.
And then x equals 1. Fantastic. Does it work? 5 minus 1 is 4. 4 plus 7 is, oh. Wait, no. Square root of 4 is 2. 2 plus 7 is, oh, no. Doesn't work. 2 plus 7 is 9. So this is what you would do literally. You'd scratch it out, and you would say extraneous.
You have to stretch it out?
Yes, my brothers. You got to show me that that solution was extraneous. Sometimes people will say no solution. You know, that's technically correct and technically incorrect. It's technically incorrect because no, there was a solution. It just didn't work. Thank you, my brother. You took the words right out of my mouth. So just because the solution is extraneous does not mean there is none. There is a solution. It just happens to be extraneous. All right. Okay, now we're going to get a little bit tougher. Now we're going to get into going old school. We're going to have some factoring and some old skills. First off, the radical's already isolated. Thank you. How do I get rid of that radical? In this case, the square root, so I'm going to square both sides. Okay. Do you guys remember when we were multiplying polynomials? I told you to learn these forms. Okay. First off, most people are going to put, oh, this is x squared plus 1. That's wrong. That's wrong. Okay, some people are going to say x squared minus 1. Okay, great. That's wrong. Okay. This, if you guys remember, it's not a difference of squares. It's a perfect square binomial. This is x minus 1 times x minus 1, and you FOIL. If you want to go ahead and FOIL and do it the long way, that is fine. I'm not going to do it at this stage in the game. It's the first term squared minus 2 times the first term times the second term plus the second term squared. Now I'm going to subtract x and subtract 5 to both sides. So now I have 0 equals x squared minus 3x minus 4. Now I'm going to factor. If I can't factor, you guys already learned the quadratic formula. And you know how to complete the square. So please don't tell me, oh, Moro, I can't answer this. It's not factorable. That's great. Use completing the square, the quadratic formula. That's why we learned it already. So what times what is negative 4, but when I add it together is negative 3? Great job, guys. Beautiful. I'm very proud of you. And then zero product property, x will equal positive 4, negative 1. Let's see if it works. 4 plus 5 is 9. Square root of 9 is 3. 4 minus 1 is 3. The 4 works. Negative 1. Negative 1 plus 5 is 4. Square root of 4 is 2. But negative 1 minus 1 is negative 2. This guy does not work. And that's, I'm going to put EXT because that's extraneous. Super huge important, my brothers. Yes, sir, my man. For this one, you would leave the answer exactly the way I have it here. I'm not even being sarcastic at all. Please. Just like this. Because I want you to show future teachers or readers of the paper, okay, guys, because you're going to have to do this, unfortunately, whether you're going to be a lawyer, a poet, an architect, a veterinarian, a teacher, whatever you're going to be, because you got to continue in school. So please write it like this, because that shows me or the reader, hey, this young person knew that the answers were 4 and -1, but not only did they know that those were the answers, but then they tested it and they found out the -1 was extraneous, okay? How about this bad boy? I'm going to subtract the 4, very good. Very good, gentlemen. Very, very good. I'm going to cube it this time. Excellent job. So now the cube gets rid of the cube root, leaving me with 3x minus 12 equals -27. You're on it, dude. Thank you. Add the 12 to both sides. Very proud of you guys. 3x equals -15. Beautiful. Divide by 3. X equals -5. Let's see if it works. -5 times 3 is -15. -15 minus 12 is -27. The cube root of -27 is -3. -3 plus 4 is 1. Word. Works. Does that make sense? Okay. Now wait. We have a lot more here. Yeah, we have 2 more pages. Okay. What we're going to do is we're going to do this last example, guys. And we're going to call this part 1. I'm not going to just throw this on your plate and expect you to figure it out on your own. Tomorrow what we'll do is first thing in class, we'll get right back to it. Okay? So let's end it on a good note. Tell me what to do for C.
+4.
Add 4. Very good. So I got cube root of 3x plus 1. And someone already told me it was -4. Someone also told me cube both sides.
3x plus 1.
That's right. 3x plus 1 equals? Not -8. I'm sorry. Wait. When you don't add the right things, you get the wrong answers. My bad. Wait, hold on. So this is add 4. So that's -2. So that equals -8. You're 100% accurate. Subtract the 1. 3x equals -9 divided by 3. X equals -3. Let's see if it works. -3 times 3 is -9. Plus 1 is -8. Cube root of -8 is -2. -2 minus 4 is -6. It works. We're going to stop right there. May God bless you all. Thank you very much. Hope you had a good day and you learned a lot. Bye-bye. Thank you. No.